So for today, we're going to talk about how to graph sine functions. Tomorrow, we'll talk about how to graph cosine functions. They're very similar in kind of how they look, but they do have some differences in mainly like where they start, where they end, kind of what their pattern is like. And we'll go over how to find all of that for both of these functions. But I want to first just kind of go over what does it look like when you're graphing sine. So sine is a periodic function, which means that it goes in regular intervals over a cycle. Okay, so it kind of has this curved shape to it. So I kind of have a picture of the graph of sine here, where it starts at 0, 0. If you think about like your coordinate plane, it goes up, then it crosses down that x-axis and it comes back up, and it's going to continue to do that. So it's kind of got this constant like wave to it. So I could keep graphing sine. It would have the same pattern, so it's just going to keep following that same nature that it looks like right here. This would be known as a cycle or a period. So it's got the start to the end in it, and then after this point, so here's the start, here's the end, it would repeat itself. So it would go back up again, and then it would go back down, and then it would go back up, and then it would go back down. So it's going to repeat itself over that period of time. And if you notice on my axis down here, I've switched it to degrees. So I'm not looking at like 1, 2, 3, 4, 5, 6 like I normally do on a coordinate plane. I'm switching this now to talk about degrees, because that's going to be broken into like what are some of the key points that are on my sine function. So for this one, like this is called the parent graph of sine. So remember, parent graphs are like what started it all. So what everything comes from originally. It's the original graph. It's really basic. It doesn't have anything really fancy or special happening to it. So this one has some basic points here, like that 0, 0. The highest point here is at 91. So at 90 degrees, it goes up to 1. Then it crosses again at 180, 0. And then the lowest point is at 270, negative 1. Then it crosses again at 360. And like I said, that's where it's going to end its cycle, its period, and it's going to continue to do it again. So it's going to go back up, and then it's going to go back down, and it's going to continue in that shape. So a lot of times when we look at graphs, you guys have been used to making like XY charts when you're trying to graph points. This also could be represented that way. So like x and y equals sine of x. My x values would be some of these key points that I outlined. So like 0 degrees, 90 degrees, 180, 270, and 360. And then when I plug those in, so like if I actually type in a calculator sine of 0, sine of 90, sine of 180, and I keep going, your numbers that are going to pop out are going to be 0, 1, 0, negative 1, 0. The reason why it's important to know what the sine function looks like is because, like I said, all of the graphs that we do today are going to be based off of the parent function. We're just going to maybe start changing some things about the parent function. We're going to start adding in numbers. So it's not just going to say sine of x. It's going to say 2 sine of x, or sine of 2x. Or it's going to start adding in those numbers in there, so it changes, it transforms that parent graph. In general, our sine functions look like this. Y equals a times the sine of bx. Now, I don't know if your guys', I think your packets, you need to write in that a. I don't think I included that. I found that after I printed them, of course. So a has to be in front of the sine. And then you have bx is in the actual sine function. Okay, so what do these pieces mean? We have something called amplitude, which is the a value and its absolute value of that. So whether it's a positive or negative in the front, when we talk about amplitude, it's going to be a positive number. Amplitude basically tells you how far from the x-axis you're going. Are you going up and down 3, up and down 2? That's what will make the graph like stretch or compress. So it'll even have like fractions in there, like a half or a third, and that'll compress the graph down. So it'll still have that curved shape, but it might just be moving a lot slower. The period, this would tell you like how long it takes for the cycle to happen before it repeats itself. You take 360 divided by whatever b is, and b is going to be whatever's in front of the x term after the sign. Then the third thing is to find 5 key points that we could graph. To do that, after you found your period from step 2, you divide that by 4, and that'll tell you how far apart they are. So when you're looking at your graph and you're labeling it, that'll tell you how far apart your degrees should be. So like on that parent graph, they're all 90 degrees apart, because 0 to 90, 90 to 180, 180 to 270 are all intervals of 90 degrees. But you could have intervals of like 30 degrees, 45 degrees, 60 degrees. It can change depending on what the function looks like. So the first point is going to be x equals 0, and then you're going to add whatever that period divided by 4 is to get your next 4 points. So that's going to be when you add 90, or you add 45 or 30, whatever it is that it comes out to be, to get your 5 key points that you're going to graph. So let's take a look at an example here together. So I've got y equals 2 sine of 3x. The first thing I'm going to do is kind of those 3 things up above. Find the amplitude, figure out what the period's going to be, list off my 5 key points, and then start to graph it. Okay, so step 1 is that amplitude, which I said is the absolute value of a. Okay, the a for this one, remember your functions are written in this form, a sine of bx. So a is going to be that 2. So the absolute value of 2 is just going to be 2. So like I said, this basically tells us that you're going to go like from the middle of the graph. You will go up and down 2. So like I said, this is the number that tells us whether the graph got stretched or if it got compressed. Since it's a whole number greater than 1, it's going to stretch the graph. That means it's going to make it a lot taller. Okay? Step 2 is to figure out what the period is. Like, how long does it take for this graph to do a full cycle before it repeats itself? So remember, your period is when you take 360 divided by the b. So we're going to take 360, and for my b, okay, so that's after the sign. It's the number that sits in front of the x. That's the 3 from my equation up here. So I'm going to take 360 divided by 3, which is 120. So what that means is from 0 to 120 degrees, that's how long it's going to take for this whole function to go up and to go down, and then come back up to that x-axis before it starts to repeat itself. Okay, step 3 is to find 5 key points. And that's when we do our period divided by 4, because this tells you like how much space is in between, like what's the interval that we're moving as far as degrees go. So my period I found to be 120, that was from step 2. So I'm going to take 120 divided by 4, which is going to be 30. Okay, so that means that we start at 0 degrees, and we count by 30 degrees. Okay, so start at 0, and we go up by 30. So 30 degrees, 60 degrees, 90 degrees, and 120 degrees. Those are my 5 key points. So now you guys should see in your packet that you already have a graph. Okay, so this is where we're going to put it. And I do have it labeled that it's showing you like there's nothing written on that first kind of dash on the x-axis. That's where the 30 degrees would go. Then the next one's 60. That's written in there for you. The next one would be 90. And then you have 120. The next one would be 150. Then 180. Okay, now we're not going to actually graph anything past 120 because I only really need to see one cycle of the sine function. I don't need to see the whole thing. So at this point, if you think about that sine function that I showed you guys up above, the parent function, so up here, basically what I'm doing with the 0, the 1, the 0, the -1, the 0, I'm taking all of those numbers times the 2, because the 2 was my amplitude. So remember I said that 2 kind of told us how far up and down from the x-axis we're going to go. All right, so like I said, you guys on yours, it looks like this. Where they're kind of skipping over one and then they're labeling the next one. So remember I said that really if you wanted to, you could write in this is where 30 is. This is where 90 is. Okay, so we're only going to graph from 0, 0 to 120. So I'm only going to use a portion of this graph here. So we start at 0, 0. At 30, my amplitude is 2, so that means I'm going to go up 2 from 30. At 60, we come back down and we're on that axis again. At 90, we're going to go down -2. And then at 120, we're back up again on the x-axis. So now we're going to draw in the curve. Okay, when you guys draw this, these lines should not be stick straight. They should not be like V's on your graph. It should be a curved line, okay? Sine functions are curved. They're not straight lines. Now, this would continue to repeat itself. So after I got to 120 here, if I really wanted to, at this next point, 150, I would go back up to 2. 180 would be at 0, 0 again, or at 0, I should say. Then at the next one, we would go down -2, and then at 240 would be the another end of another cycle. So I could continue to draw in more of the sine function if I wanted to. Really, I just need to be able to see kind of those first 5 points to make sure that you understood where it all came from and kind of how it all got figured out. If it helps you, I'm just going to add this in onto the side here. Like I showed you that parent function up above, I said x and then y equals sine of x. And those numbers were 0, 1, 0, -1, 0. You can do the same thing with this new one. This new one, though, is that 2 sine of x. So it's going to change your numbers from 0 to 1 to 0 to 2, 0, -2, 0. Now, you don't necessarily need that because you do already have it graphed, but that's where that's coming from. I don't know why I wrote 36 there. That should be 30. Okay, so the parent graph would have kept you at 0, 1, 0, -1, 0. That 2 in front causes it to shift up a little bit more. So it's going to cause this to stretch. All right, let's turn the page. We're going to do another one together before you guys try one on your own. All right, so this next one here we have y equals 1/2 times sine of theta over 3. So first of all, the number in front is 1/2. It's not 2, so we're dealing with a fraction here. That means that this graph is going to be compressed. So it's going to be kind of squished down. So it's not going to go as tall as that last one did. Now, sine of theta over 3, if that's confusing to you, you can think of it like this. Y equals 1/2 times the sine of 1/3 theta, or you can replace theta with x, okay, because it's just talking about the angle. All right, so let's do those couple of things again. So step 1 was our amplitude. So that's absolute value of A. So that's going to be absolute value of 1/2, which is just 1/2. Step 2 is to figure out what the period is going to be. How long is it going to take for our cycle to stretch out on our graph? So for the period, remember you take 360 divided by the B term. So we're going to take 360. The B is that 1/3. So really you're taking 360 times 3 because you're trying to divide something by a fraction. So if you take 360 divided by 1/3, or you multiply 360 times 3, that's going to be 1,080. So this graph is going to be stretched out a little bit more. It's going to take longer for the whole cycle to complete itself. Step 3 is those 5 key points. So remember, you take your period divided by 4. So we're going to take 1,080 divided by 4, which is 270. So we start at 0, and we add 270. And you're going to do that till you get 5 points, and your last point should be that 1,080, because that's where the period stops. That's where the cycle stops for the graph. And then it would repeat its pattern. So you're going to add 270. So 270 plus 270 would be 540. Adding 270 again gets us to 810. And adding to 270 again gets us to that 1,080. Now, with your guys' graphs, even though there's numbers written on there, if the numbers that are written on the graph don't work for your problem, you can relabel your graph. Okay? So like the one that I have in there, it doesn't have anything on that first one, and it goes to 360, and then nothing, and then 720. It doesn't really work for what I want this to do. So I'm going to relabel it here. I'm going to have that first point be, I'm still going to skip over 1, just kind of give myself some more space. So I'm going to call this first one 270. Skip 1, go to the next, 540. And I'm going to keep doing that to get my points on here. So what I did, like in your guys' packet, I just crossed off 360 and I wrote 270 instead. I crossed off 720 and I wrote 540 instead. You can relabel these to make it fit your problem, if that's necessary. Okay? Now, I'm doing 1 and 2 and 3, -1, -2, -3 on that y-axis. My amplitude for this one is only 1/2. We're still going to start kind of at that 0, 0 point, but at 270, I'm only going up 1/2. That half tells us how far up and how far down from that middle of the graph we go. So because it's 1/2, we're going to have to estimate where we think that is. It's going to be between 0 and 1. Okay? So there's the first point. Then we're going to go back down to 0 at 540. At 810, we're going down 1/2. And then we're going back to 0 at 1,080. So notice how this graph, it doesn't get up nearly as high as that last one did. Okay, and then draw that in, and again, it should be curved line. Okay, kind of think about like a roller coaster. Roller coasters don't go straight up and straight down. Okay, they have a curve to them. That's what like these sine and cosine functions look like. They have kind of that, like you're driving through the country and you're going up and down hills, okay? I want you guys to try the third one there on that page. That's the last one. I want you to try to do all of this. Find the amplitude, find the period, 5 key points, all of that. And then try to graph it. Okay, so I've got my amplitude, my period, and then I'm working on my 5 key points here. So I found my amplitude to be 4. That means that this graph is going to be stretched. The cycle is going to be from 0 to 720. That's how long it's going to take for us to see the full length of this graph. And then my key points, I'm taking 720, my period, divided by 4, which is 180. So we start at 0, and then we work up by adding 180 each time until we get to that 720. Okay, so there's my 5 key points. Now I think the graph that we have works because it's got 180, 360, 540, 720. So we don't need to relabel that one at all. All right, so we start at 0, 0. At 180, you're going to have to go up 4. So let's see. I'm going to be 1, 2, 3 up here. Then at 360, we're back at 0. At 540, we had to go down 4. Because that's all based off of my amplitude. That 4 is telling me how far up and how far down from the middle I go. And then back at 720 is where we come back to 0. So this graph should have been a lot taller than some of those other ones because it's being stretched more. Okay, and then draw those in. And I would make sure that you are drawing arrows on either side of the graph because it is going to continue to go forever. Okay, just like any other line would, sine functions continue to move forever as well.